Thank you for having me. The topic I'm going to talk about today is robotic research and applications for occupational safety and health. So before we start, I would like to talk about what is a robot. I think currently the most well-known robot is Tony Stark. However, nowadays our technology still cannot make Iron Man. So instead of having an Iron Man, what do we have? A robot can be defined as a machine that can be programmed and perform certain autonomous actions. So when we have this definition, we can call it a robot. But keep in mind, robotics is not the same as automation. When we talk about automation, it means that we have multiple devices that can do a series of tasks, and all of them are collaborate among each other to perform a certain task. So when we are talking about robots, it's more like autonomous, but instead of automation. For robotic and worker safety health, emerging industrial robotics technology will bring both potential and concerns in worker safety and health. Robots improve quality of workers' life by taking over tedious, dangerous, and dirty jobs that are fatiguing or less safe for human to perform. We will see some examples for robots replacing dangerous tasks for human workers in the next few slides, but we still have some concerns that include the use of robot is likely to increase the injuries, new type of injuries for human workers. And we have new type of robots will bring some kind of hazards. So we need to have new protection strategies to guard human workers away from those dangerous things. And the rapid advance of technology may outpace standards nowadays, so we need to have some new standards for new robots. And also, human workers might have stress associated with changing workspace and potential for displacement because robot is so convenient. Somewhat, the employers might want to use robot instead of human workers. So the outline for my talking today include a few things. The first part, I'm going to talk about the background of robots and future trends. And I'm going to talk a little bit about the Center of Occupational Robotics Research at NIOSH. Also, I will be discuss the research needs using robotics and some ongoing projects we have at NIOSH. Then I'll draw some conclusions. So robots nowadays, it's not easy to define what robots are, and it's not easy to categorize them either. IEEE Institute of Electrical and Electronic Engineers has categorized 15 types of robots. It can be used in various fields, something like industrial robots, medical applications, and you might also have one robot at home to take care of the floor cleaning for you using Roomba. But are robots safe? Well, traditional robots, because they are huge power, so they always fixed or in a place or caged. So from 1992 to 2015, there are 61 fatal records based on robots. I cannot say that it's good or bad because it's good compared to vehicle accidents or other accidents, but it's bad if you are one of the member of victim's family. So that's a reality. We have 61 traditional robot-related deaths in those years. But nowadays, new collaborative robots has been used in various kind of industries or human-robot interacting environment. So new standards must be set for those new robots, and those standards has been set up in early 80s, but nowadays we still need to have those standards to evolve so that they can fit the situation nowadays. Some of you might likely too familiar with upward trend of industry robot as you see in this picture. So this year is 2019. So far, in 2018, based on the statistical data, we have already more than 300,000 industrial robots instead, global-wise. In 2025, I think it's going to be more than 7,000 sets of robots will be used in industry. Just like the industrial robot, the robot will be widely adopted by medical applications. So in last year, there are more than 3,000 sets of robots being used, such as surgical or healthcare or other rehabilitation tests using robotic devices in North America. By 2022, it's estimated to have more than 7,000 sets of robots will be used for medical applications. So, what are medical robots being used in this area? Based on the American Society of Mechanical Engineers, top robotic applications in medical and healthcare applications include telepresence, surgical assistance, rehabilitation, medical transportation, sanitation, and disinfection. And the other one is robotic prescription and dispensing systems. Those things are the things popular last year, but keep in mind the technology is evolving. There are some micro robots or nano robots which swallow it and have those robots moving within human bodies to dispensing something that need to be some dose of medicine daily. You might just swallow the robot and it will do everything for you for a month or a year. So those kind of things is under development. In the next few years, we might have different robot on this list as well. I'll be talking about the Center of Occupational Robotics Research at NIOSH. So in 2016, NIOSH formed a work group to identify the current and future research needs for occupational robotic safety. The effort led to the establishment of the Center for Occupational Robotics Research, or we call CORE, in 2017. Our mission is to provide scientific leadership to guide the development and use of occupational robots that enhance worker safety, health, and well-being. So what is the scope of our center? The center aims to address traditional industrial robots as well as evolving robotic applications, including collaborative robots, mobile and coexisting robots, and wearable robots, remote control, and some other autonomous robots, and future robots work with integrating artificial intelligence. So I'll give you some examples what the robots has been applied in industry nowadays. So in shipyard work, welding read manually onto the steel plate requires the worker to kneel on the plate. This task results in significant stresses to the worker's back, neck, and legs. So if we can use robot to replace human worker. There are few benefits. They can reduce muscular and skeletal disorders and produce higher quality products with better consistency. Those kind of robots have been applied in Japan. So those things can actually enhance the health of a human worker. Another example I would like to share with you is many lab tests are monotonous, requires precise process. However, those processes might pose some potential risks if they are performed without adequate personal protective equipment. So those robots can help us to perform those tests, and we don't need to worry about they'll be poisoned or something bad happen to the robots. They can be precise and power efficient. Another thing that is healthcare service robots. Transferring a patient from a bed to a wheelchair or vice versa is one of the most strenuous tasks for healthcare worker, especially to their lower back and upper extremities. Service robots can be used for this kind of assistance so that they can reduce those injuries occurred while moving the patient from one place to another. In addition to the robots I showed in the previous few slides, we have other kinds of robots for healthcare. The first thing you see over here is exoskeleton. So some people might have injuries in their backbone or some part of the frame, so they might have difficulty to walk like regular people. So exoskeleton robots can actually provide additional force to help them to perform their daily activities. And another thing is we can have robot to do a repeated test. So this can be assist the patient, stroke patients for their rehabilitation activities. Another thing is we can see a lot of smart wheelchair nowadays that can provide patients better mobility with better detection capability of surrounding conditions as well. So you can find those things, you can find NIOSH strategy plan which related to the research applications we talked about in the previous few slides. You can also find out the research needs on our website as well. So one of the models that we use in our center to develop research priority is a public health approach. There are 4 elements in this approach. They are including the risk identification, which seeks to understand why and how robot-related injury incident occurs. And the second one is incident surveillance. So this defines the methods and techniques for data analysis. And the third one is intervention. So the intervention includes design, implementing, and evaluating risk controls to develop a working model of injury prevention. And the third one is translation. So for this one, we set up the strategy to translate the research findings into practice. So we're going to talk about a few potential research needs required for industrial and medical robots. Robot technology has been rapidly advanced, and new types of robots have been introduced, as mentioned in the earlier slides. Collaborative robots, or we call it cobots, will drive the industrial robot market. Cobots are designed to work directly with humans within a shared workspace. We might need to know the human robot interaction model so that in the future, when we are developing those robots, those models can be integrated in the design. And the second one is mobile robots is also growing. Mobile robots can move alongside in a shared space with human worker. You might find those robots in warehouse. So if you go to Amazon warehouse, you're going to see a lot of those kind of robots helping to pick up boxes or packaging for human workers. In the future, in hotels, you might find those robots actually helping travelers to move their luggage from the main door to the individual rooms. And in hospitals, you might also find those robots helping medical staff to carry supplies or moving the patient from one room to another. However, there is one important thing we need to keep in mind. Nowadays, the robot is interacting with human workers. So interaction between human and robots is an important issue. Sometimes we might need to give commands to a robot directly, so that might require some kind of artificial intelligence so that the robot can respond to the command directly. And we might want to use oral commands. We might use some gestures so the robot can understand us quickly and efficiently. So you might have Alexa at home. So you know those kind of artificial intelligence can actually distinguish what we want them to do. So that might be something we're going to see in robot in the future, in the near future. Another type of new robots is wearable robots or powered exoskeleton. Those robots can reduce mechanical stress and amplify or transform worker movements. Those can be found in many research projects. And nowadays, I think a lot of them are still under development, and some of them are using in military research projects as well. Other than those kind of traditional robots we talk about, drones is actually one of the type of robots. So drones can be used to operate in indoor or outdoor for various applications. Maybe we're doing agriculture observation. We might use those things to do some kind of observation for construction. Those robots, those drones can not only monitor the outcome quality of the products, they can also help us to monitor the safety of human workers in that environment, because they might not be so easily to be accessed in that environment. So drones can actually be a very good assistance for us to monitor the safety of the human workers in that environment. Automated ground vehicles and autonomous vehicles are also considered as one type of new robots. Those things like Uber or other Google car, they can be treated as one type of robot as well. And now navigation and communication among those robots are important research topic in academics and industries. The other thing is robots also help manufacturing industry to perform repeated tests and lift heavy components. Nowadays, many car assembly lines are operated in a collaborative environment, which both human workers and robots are working together. So you can see the difference from those two pictures. You can actually see a difference. One picture on your left-hand side, you see a lot of human workers in the workplace, but on the right-hand side, you probably only see one robot working together with a single human worker. So that can be more efficient because the robot can actually lift up heavy stuff and precisely assemble them to a specific location, and the human worker might just do the things need to be taken care by human being only. So those things are the environment nowadays, and it can be migrated to various industries in the near future as well. Another thing, recently, remote medical service starts to integrate robot with telepresence. So the goal of this kind of research is to integrate robots that can mimic movements of both patients and therapists. So with the assistance of robots, physical service can be provided remotely in real time. The service, this kind of service is going to integrate virtual reality, cloud storage, control theories, human factors as well. So this is something we call cyber-physical systems. That can be they can provide the medical service remotely. So one side, on the therapist side, we have a robot that is going to mimic the other side while the patient is moving. And on the other side, the patient is going to have some kind of virtual reality glasses, so they can visualize what the therapist is actually doing, and they will follow the movement driven by the robot. So real-time therapy can actually be performed using cyber-physical system like this. So those studies are the research nowadays in academics and industries. At NIOSH, we have several research projects going on related to robots as well. So the first one I like to talk about is measurement of dynamic force impact of cobots on humans. So this is important because we want to prevent injury while doing those kind of while human workers is working in a collaborative environment. So you need to know how much force when the robot hit the human being, that is going to induce injury. So we need to know what is the maximum allowed force and what is the maximum allowed speed for the robot that can interact with human worker. So we want to minimize the force transfer from or energy transfer from the robot to human worker, so the injuries can be prevented. But because it's very unlikely we can say the robot is totally stopped. Sometimes it's not possible. So we need to know when this kind of scenario is happening, can we move the robot to the minimum allowable speed so the injury is not going to be happening? Another thing we're going to do, we're doing at NIOSH is smart path planning. So based on what we're talking about on the previous slides, we want to minimize the impact. However, instead of impact, we want to have the robot to actively avoid contact with human worker. So we try to use some kind of artificial intelligence algorithm to plan the moving trajectories for robots. So the robot is going to actively avoid the occupied spot of human worker. And if the human worker approach the robot, even though the robot is stopped, they can actively move away from the workers, so injury can be prevented. Another thing is we're doing is human-robot interaction. So this is important because we might be afraid of a robot. Let me give you one example. I have a Roomba at home, and I have 2 cats at home as well. So when the Roomba is moving, one of the cat is really afraid of it, the robot. So it will just go to some place the robot can never find him. And the other one seems to enjoy the free ride provided by Roomba. So you can see the cat right on the robot all the time. So those things, those behavior are different. We might feel the huge robot in front of us are safe if they are not moving. But if they are moving, we want to know how fast we still feel comfortable. And we want to know what the distance or moving speed is fit for most human workers can do. So this will be can be integrated in the standard in the future. So we know the distance and we know the moving speed. So the human worker can feel comfortable working with robot together in a collaborative environment. We're going to have this. We're going to verify our findings virtually using virtual reality, and we also have we're going to do the experiment physically using real robots as well. Another thing we are doing is actually in mining program. So we have a very different type of robot. It looks like a snake. So those robots can actually go to the environment that is hazardous for human workers. We might not be able to go into the spot because it's dangerous. So those robots can actually help us to explore the environment in that spot that we are not allowed to go to. Or if there are some accidents happens, those robots can actually use for disaster rescue devices that go into that area and try to help us to identify survivors or other stuff. One other thing I like to talk about is integration of artificial intelligence. So nowadays, artificial intelligence is not so powerful. It will understand everything. Just like you see the movie AI, it's very unlikely. Nowadays, we're still using some kind of algorithm to identify small parts of what we targeted. So this one over here is we try to identify the human motions in real time. So if we are using time sequence you can see that on your left-hand side, it's somewhat a little bit difficult to know what's going on. But if we are using image or other representation, that we can see a difference. So if we collect enough amount of data, we can use artificial intelligence algorithm to predict what the motion is going to, what the motion the human worker is going to perform. So at this moment, we can use 33% of the data to then we predict what the human worker is going to do. If we are using 33% of the data, the accuracy is actually above 97%, depending on who is doing that. So you can see the figures in the bottom over here. You can see it's just 20%, 33%, or 50%, or 100%. You can see after 33%, it's almost finished everything. So you can identify the characteristics of those motions and predict what's going on in real time. But the drawback is artificial intelligence still computation intensive. So even though we are using i7 using a lot of data and using very powerful CPU. It requires us 1.2 seconds. Is that fast? I don't know, because motion is typically 6 seconds. 1.2 seconds means that you are waiting for almost half of the motion being performed. Is that safe enough? Maybe yes, maybe not. It requires a future study to know whether it's good or not. Okay, so finally, we're going to talk about future robots. So obviously, future robots is going to integrate a lot of different kinds of things, sensors, different kinds of sensors. Because sensors, sometimes we might put sensors at specific spot. So if we are trying to detect the force, we can only detect the force at a certain location. In the future, we hope we can have some kind of a sensor array that are going to integrate it with the robot. And also, we would like to have artificial intelligence to be integrated with the robot. So the robot can be taking care of some specific tasks. Most of them can be dangerous or repeated tasks. So that is something future robots is going to integrate and help us to change the landscape of labor and workplace environment. Conclusions. So industrial robot will expand fast. Next decade, we will see a rapid growth and new application robots in workspace and healthcare. Robotics held much promise for improving workers' safety and health. However, advances in occupational robotics can have potential to increase risks for worker injury. That will require new and refined prevention strategies. NIOSH and occupational safety and health professionals and community should be proactively engaged. So that's my conclusion. Thank you for your attention.